too. This is Stan Cloyd, Mesa, Arizona, doing a video on vices. Back in the 20s or 30s, a gentleman by the name of W.C. Fields described his behavior with respect to vices. It said, "I spent half my money on gambling, alcohol, and wild women. The other half I wasted." Well, as hobby machinists, we also spend a lot of money on vices, but however, the expenditure is a lot less objectionable to our wives and sweethearts. I did a vice. One of the vices I recently bought was a split vice from the Pacific Rim, and it didn't work. And the reason it didn't work was that it would slip. You put it on a mill table and torque it up, and it would slip. And so I had to add a bunch of parts to it to get it so it didn't slip. And then when I got to the end of that, I quit putting stills on Facebook's YouTube channel and made a video where I actually showed you how I proved that it could develop full clamping force and it wouldn't slip on the table after the mods. I'll put the link to that video in the comments so that anybody that really wants to see it can. I'm kind of big on testing methodologies. I don't have as big of a surface plate as many of the contributors on here, and so these videos on vices are more of a static review of how they are once you torque them up. And so Dale Derry did a comparison of these two types of vices a few years ago, and he did a very good job, and he did a nice job with the surface plates and the mechanical analysis of the vice, and that's fine. This goes to maybe a bridge too far in where I put stock in it, torque it up, and you can look at the dial indicators. In one of these tests, when I did it, I didn't understand exactly what I was doing, of course, so I clipped the magnet of the dial indicator to the back jaw and put the plunger on the front jaw. So when you see the deflections of the vice, all you're seeing in my video is the relative deflections of the two. You may not know if the back one's flexing outward or if the in one's taking a dive. But nonetheless, you can see the difference in rigidity when I compare these two vices under load. And when I was doing the split vice, many people said, well, put keys in it. And so, yeah, I put keys in it. I made steel keys. And I found out I had to make them about 10 thousandths loose so you could still tram in the halves of the split vice. As I was getting ready for this one, I put some stills on YouTube, and Bruce Whittam of Australia pointed out that he never used these turntables because he needed all the headroom he could get on his machines, and he had 6 vices and never used a turntable. All right, well, I'm using turntables. But also, you'll notice that I put in a riser block to get that headroom between the tooling and the part being worked on. Bruce Whittam also put a riser block in his Jimbo, and we got to see him struggling to put it in to some extent. Dale Derry put a riser block in one of his, and he had a video on it for a while, but I think it's been taken down from his channel or marked private. His channel Built Something Cool. Be that as it may, he discusses a lot of the human factors and the pros and cons, and that's all good. When I put this one in, I made a video, and I lifted the top of the fixture and pushed it on the trolley, and it went toward the camera so fast I had to run down here and grab it before I dumped a $3,000 camera on the concrete. So that video, I don't know whether to link to it or not, but if you get to my page, you can look it up if you want to. Might be good for a laugh. Anyway, I got into, since I am using a vise with a turret on it, I'm going like, well, how do I put this on here so I've got repeatability and it doesn't take me so damn long to tram it in? So I decided to make keys for it. And I cut them even a bit more narrow than I had so that you could manipulate the bottom of it without manipulating the angular part in normal day-to-day usage. And so I looked up some parts on McMaster Carr, and they are called slotted spring plungers. And I bought 2 different versions of them. in the ones I built for the Kurt vise were the ones I did first, and they are a part that is 1/4 20 thread. And then of course on the Grizzly vise, after I refurbished it to the best of my abilities, I made another one, except this time I didn't do it in steel, I did it in aluminum, and I didn't do it in 1/4 20 threads, I did it in 5/16 18, which eases it up a lot. And I'm like, do these keys really need to be in steel? Well, I kind of don't think so, even though the aluminum costs $1 or $2 more. I'll walk up so you can get a view after she autofocuses. This is the end of a typical key. The slot in the vise is a little wider than the slot in the table. For most of us, that's probably true. And in my case, I put these balls in, and I had to place them in such a way that they didn't intersect the bolt holes that hold this thing on. And then on this side, of course, you've got the screws where you can adjust the clearance and the tension on them. So if each ball is giving you 10 pounds, then you've got 60 pounds of force pushing the vise into the back half of the slot. And one of my big questions was, what's the repeatability of this? If I haven't manipulated the angles and I just use the base, I throw it up there, how close am I going to be? And in the last part of the video, you get to see that. So let's dive in. Okay, this is the setup I used to tram these 2 vices to the mill table. This, of course, is the Grizzly vise, the economy vise. And this is the Kurt DX6 crossover. Both of them have been trammed right here to 5/10. And that's the lowest graduation on my dial indicator for that kind of thing. They're locked down on the turntable, and the adjustments were made at the bolts that hold the vise to the turntable, or the turret, if you will. Okay, and so I'm going to pull them both off, swap them in position, put them back on, and then I can show you how far off these rear vise jaws are with just the springs in the special keys pushing them up when we lock them down from the bolts to the table. I don't know if it's going to help any or not. It's an interesting experiment. We'll see. Get to it. Well, as you can see, I swapped these vices around at high speed with little tricks of photography there. So both vices are locked down. They were put up against the back edge of the T-slots by their sprung balls, and they are ready to show the tramming in of it. How close did we get? The turrets stayed locked, the rotating turrets, and we used only the base with the keys in them, with the spring balls in them, that tend to push the vices that way when you lock them up, 50 to 100 pounds. And of course that makes them hard to pick up, and they kind of snap down. You probably didn't see that in slow-mo with the chain hoist. But anyway, be that as it may, I've got this camera on autofocus. Hopefully you can see this dial indicator as I stroke through it. I've got it set to 0 on that edge of the Kurt. And it seems to be holding up all right. Let's see where we're at. Yeah, we're within a 5/10,000ths side to side, and all I did was move it from here to there and lock it down with the springs holding it back. So on that one, it was a win. Now we get to see how well we did over on this one. The old economy vise from Grizzly that I had to do a lot of work on, and you saw that in the earlier segments. This should be the last segment, unless I want to add something as a trailer. And in fact, why work that hard? There we go. We love it. If you've got the right Gibbs lock, you can get almost the same results this way as you can the other way by hand. I don't like to do it in power mode unless I'm roughing. Okay, we can bring this one down a little bit and get it engaged. Like so. And then we can back out the... I have to unlock it, of course, and then back it out till I get a 0. Coming up on a 0. There we go. We got a pretty fair 0 there. You can get a little closer, but when you end up having to slightly lock your gib as you tap on the handle if you really want to 0 it in. Tap on the handle with a soft mallet. Okay, that's close enough to 0 for this little demonstration. Now, this way's locked, this way's locked. We're able to go this way, and we'll do it by hand. Like I said, I could also show it by power, but I prefer not to. No, I don't know how many thousandths this one's going to be out when we get to the other end. This one has higher tension spring balls in it on the old one, because I did it second. I did the Kurt first, and as you saw in earlier sections, well, that's pretty damn good. Pretty close to 0. Oh, there we go. Well, I got some slop in my gibs. So if I go all one way and keep going all one way, I get the right reading. When I back it up, obviously I'm getting something else. And it's holding pretty well. It's not the best. Let's see if I can tighten this gib. Now the gib takes it back to 0. So we'll lock our gibs and 0 it again. Our cross slide gibs. Okay, it's close enough to 0. So we'll loosen them up, go the other way, and then hit the gibs again. With power this time. Alright, we don't like to do that. Now we're going to lock these gibs. We're half a thou out. Lock those gibs and we're back on a thou. So, the proof is in the pudding, as they say. I like what I see. I wouldn't trust it. In other words, if I throw them up there and I need accuracy, I would still tram it. Even though we've pretty well demonstrated here that you're awfully, awfully close with these sprung ball keys. And I'll have to do the earlier sections that show you what that's all about later. This whole video is shot out of sequence, but I'm sure that's not unusual. Okay, gentlemen. That's enough for this clip. All right, here's the base of a vise that I've had for about 5 years. I bought it from Grizzly, and of course it was very economical. And I used it for a long time. It was full of chips. It had coolant stains on it. It needed to be cleaned with Scotch-Brite, blah, blah, blah. And it always had a tight spot in this screw. I never knew why, but you'd go around and at a certain position you had a tight spot. And I thought it might have a bent screw in it, but it does not. It did not. What happened was that this collar, this retaining collar for the thrust washer, the thrust bearings, had a high spot on one side that had to be reclaimed before you could get it so it's smooth all the way around like the premium Kurt vise. Alright, so the old timers know how this works. If you're a newbie like me, you don't necessarily. These vices have a mechanism that clamps the top jaw down. The tighter you push against the material, the more it clamps the top jaw down. And I think the idea behind that is to eliminate jaw lift. If you don't have it, you've just got a regular screw block, then you're not, it'd be more like a drill vise or whatever instead of something pretty nice. Anyway, this one has an upper jaw, and in that upper jaw there's a half of a ball bearing like that. I've got it retained with anti-seize, and so that it stays in place till you get it together. And then in the lower half you've got this hook angle, and what this does is push on that ball. The resultant force is down right about here, so you've got this force here and this force here, and the ratio of distances should mean that you've got more clamping force downwards than you do against the top of the stock. We'll do an experiment on that later with a dial indicator after we put it together and mount it. But anyway, I will kick this thing onto 1 frame per second so you can watch me assemble it without going to sleep. You saw me put it together 1 frame per second. This jaw on the back is keyed. It has to be off to be able to get the nut in or out. I didn't bother showing you setting up this thrust bearing here, although I finally got the tolerance on it acceptable. It was too tight, of course, when it was manufactured because of a warp in this retaining screw. You also probably saw me use an inch-pounds torque wrench to check how tight this preload screw is. I've got it about 10 to 15 inch-pounds of effort to turn that screw, and of course there's no longer any tight spots in it. And you won't find that objectionable. And number two, if you were doing it fast with the electric drill and a socket, it would easily take it, even on the lowest torque setting. Now we'll go ahead and mount this on the base of the item so we can do the next test with it bolted down to the table. And for the next test, it needs to be bolted down to the table. Here we have it, folks. I'm going to zero my dial indicator and then torque this thing up to 75 foot-pounds. We'll see how we do. I'm going to zero in on the gauge so you can actually see it accurately. I had to kill some lights to get the glare off the gauge face. I suppose that's quite common in these videos. I've got autofocus on. Okay, we're zeroed. You've seen the bigger picture. Now we're going to torque it. When you hear the click, we've hit the test spec, 75 foot-pounds. Okay. Okay, the jaw is diving because of the wedging action of the half ball and the hook on the nut. The movable jaw is dropping instead of rising. We like that. That's something we can deal with. Okay, 19 thousandths. This jaw went down due to the wedging action by 19 thousandths. Let's back it off and see how much it pops back. Okay, there's a return to zero. So on the first torque up where I didn't have the camera on, I took some slop out of the unit and because it'd been totally apart. So now we'll put the Kurt on with the same experimental setup where you got a roller between the jaws and see how it does. Okay, here's the same experimental setup with the Kurt, a brand new Kurt. And to avoid the mistake that I made on the last test run, I torqued it to 75, I dropped it from 75, and then zeroed my gauge, which you can see in the video. Okay, torque wrench, same amount of torque, same calibration. Got to make it rotate right. Okay. Building slowly. This one's diving too, but okay. The movable jaw dove by 1/1000th of an inch. So I think we've just proved that you do get what you pay for. In precision, nice assembly. Maybe this Kurt's going to live up to its reputation. We'll see.